Hello, in this 16-minute video we will explore number conversions, including how to convert between hexadecimal, decimal, binary and octal systems. If you want to jump to any specific section, here is the timestamp. The first step in converting hexa to decimal number is to separate all the numbers, all the hexa numbers given, and we will multiply each number by 16. As this number is in a decimal form E6.3, we will have to add the powers starting from 0 incrementally from left to right. The next task is to add powers incrementing from 0, 1 and onwards, whatever the numbers are given, to the left side of the decimal point. And to the right side of the decimal point, the power will be incrementing from -1. We have only one number after decimal here in this equation, which is dot 3 only, so we will add power of -1 to 16. And we can keep a number conversion table in front of us to help in the calculation as well. Now the next step is to find out the decimal equivalent of the numbers given individually. E is equal to 14 in decimal, and if we calculate 14 multiplied by 16 power to 1, it will be 224. And 6 of hexa is equal to the 6 of decimal as well, so there will be no change, and 16 power to 0 is equal to 1, so we will write 6 as it is. 3 again hexa is equal to the 3 of decimal, so 3 multiplied by 16 power to -1 will give us 0.189. Now the most simplest step of the calculation, we will have to add them all, and this is our answer. 230.187 is the decimal equivalent of hexa E6.3. We can also check this from calculator. Now we will convert 46C hexa to the binary number. The first step will be to separate the numbers. We will again keep a chart in front of us. We need to find out the binary equivalent of the numbers individually given of 4, 6 and C. We can get a help from the table. 100, 110, 1100. They are the binary equivalent of the given hexa numbers. But we also need 4 binary bit numbers. Here C is pretty much fine. Its binary equivalent is 1100, so no problems with that. But 6 and 4 has one less digit. They are 3-digit numbers so far, so we will add zeros to the extreme left side of it to make them 4-bit binary numbers. Combine them all and this will be our answer. So it is as easy as it is. We can also check this from calculator. Now we will convert hexa to octal number. D5 is the number in question to convert, keeping number conversion in front of us for the help. D equates to 1101 binary. Separate both the numbers given in question D and 5. We will find out the binary equivalent of both the numbers, but we need 4-digit numbers, and 101 of 5 is not a 4-digit binary equivalent, is not 4-digit number, so we will add 0 to the left side of it to make it a 4-bit number. We have couple of 4-bit binary numbers in front of us. Now next step is to combinedly break this into chunks of 3 starting from left, which will give us 11010 101. As we need 3-bit numbers, double one is falling a 1-bit short, so we will add 0 to the left side of it to make it a 3-bit number. And by 3-bit numbers we can find their octal equivalents. Double one is equal to 3 and 10 of binary is equal to 2 and 101 is equal to 5, and we will combine it and this will be our answer. By converting octal to decimal number, we will convert 462 octal to decimal number. The power of 8 is of octal and power of 10 is of decimal. The first thing we will do, we will separate the given numbers of the question 4, 6 and 2. We will then multiply all the separated numbers by 8. 8 because of the fact that 8 is the base of octal, if you are wondering. Then what we will do is add powers from 0 onwards incrementally from left to right. One thing to keep in mind is that power number increases as it goes from left to right, and we will perform the calculation of these numbers separately, then add them at the end of the day. And that's our answer, and we can also confirm this from the calculator. And there we go, exactly what we just calculated. Now octal to hexa conversion. We will separate all the numbers, and we have a chart on our screen which shows binary, decimal, octa and hexa equivalents of each other. Match 3-bit binary equivalent of these separated numbers, which are 4 is equal to 100, 6 is equal to 110 and 2 is equal to 10. So as we can see, 100 and 110 are 3-bit numbers, but 10 is not a 3-bit binary number. We have to add 0 on the left side of it to make it a 3-bit binary. Guys, we need 3-bit binary numbers for this calculation. If any number falls short of being 3 number digit, we need to add zeros at the left. If it was only 1, even then we will have to add 2 zeros to the left side of it, and we will combine all the numbers, and this will be our answer. We will combine the numbers and then we will separate them by 4-bit from the right side. 000010 is our first number, which is equal to 2 in hexa. 0011 is equal to 3 in the hexa, as we can see from the chart, and finally 1, which is equal to 1 in hexa. So 132 is our answer, converting 462 to the binary equivalent. So what we will do is separate the given number 462. We will keep a chart of number conversion system to help us. Now find the 3-bit binary of the separated numbers, which are 100 for 4, 110, 110 for 6 and 10 for 2. Here we need a 3-bit number, so as we can see 10 is of 2-bit, so we will add 0 to the left side of it to make it a 3-bit number. Guys, we need 3-bit numbers eventually in this calculation, so even if it was only 1, we had to add two zeros to the left side of it to make it a 3-bit number, and then eventually combine them, and this will be our binary to octal number. Let's confirm it from the calculator. So firstly we will convert 626 decimal number to the octal number. By the way, base 10 indicates that it's the decimal number and base 8 is the octal number. It's quite an easy process. We will keep on dividing 626 by 8. Here 8 is a divisor. 8 will remain same because of the fact that 8 is the base of octal number, and 262 in our calculation is the dividend. So let's start the calculation. So after the end of first calculation, what we get is 78 as the dividend and 2 as the remainder. So as we can see, 78 is less than 8. So we will continue our division process, and at the end of this calculation we get 9 as the dividend and 6 is the remainder. As we can see, we have got 9 as the dividend. We have to perform one more calculation at least. As you should know, a calculation is only stopped in this type of conversion only when dividend is less than the divisor. So let's divide 9 by 8. We get 1 as the dividend and 1 as the remainder. And naturally 1 is less than 8, so we can stop our calculation here for decimal to octal process. And we will do the reverse calculation from left to right and upwards. We get 1162. And this is our exact answer to the decimal to octal conversion. So 1162 is the octal equivalent of 626 of decimal. Now let's convert decimal to hexa. Take 2486 as a decimal number and we will convert it to hexa. Hexa has a base of 16. So we will write 16 in our calculation as a dividend and 2486 as the divisor. Let's start our first division process. So at the end of this calculation we get 155 as the dividend, we get 155 as the dividend and 6 as the remainder. So 155 less than 16, so we will continue our calculation. 155 divide 155 by 16, we will get 9 is less than 16. So we can stop our calculation here and do a reverse calculation from left to right and upwards. We get 9116. But one thing to keep in mind is 11 is equal to B in hexa. So our answer is 9B6. And finally, decimal to binary conversion. We will do it in a similar way. 122 is our number which we have to convert in binary. Divide 122 by 2, we get 61 as the divisor and 0 as the remainder. Divide 61 by 2, we get 30 as the divisor and 1 is the remainder. Again, keep on dividing. We will keep on dividing the divisor till it reaches a point where it is less than or equal to 2, the dividend, the base number of binary. And at the end of all these calculations, we finally reached a point where divisor is less than dividend 2. So we will again reverse calculate from left to right and then upwards, and our answer is this, which is decimal equivalent of 122. Take the binary number 011010 as an example to convert to octal. First, we will have to separate the numbers into 3-bit group numbers, starting from right. We see that 010 is a complete 3-bit group number, but 11 is just 2-bit number. So we will have to add 0 to the left side of it to make it 011, and now it also is a 3-bit number. We will separate both the numbers. Now we can find the octal equivalents of both the numbers. 010 becomes 2 and 011 becomes 3. These are the octal equivalents of binary. So the answer becomes 32. Now for the second example, we will take a bit complicated number 1100 As we did in the first question, we will have to separate the numbers from left to right in 3-bit numbers. And we can see 110 and 100 are 3-bit numbers, but 1 remains only 1-bit number. We will have to add 2 zeros to the left side of it to make it a 3-bit number. Now individually find the octal numbers of the separated binary numbers. 001 or 1001 equates to 1, 100 equates to 4, and 110 is 6 in octal terms. So 146 is our answer. Now let's take another example with the decimal number. So our decimal number is 110.101. Again, the process will be same. We will have to separate the numbers by 3-bit. As we can see from the leftmost side, 1 is only a 1-bit number. So add 2 zeros to it to make it a 3-bit number, and find the octal equivalents of the individually separated binary numbers, which is 14 and 5, and there's a dot in between, so this makes it to 14.5. Now we will convert binary to hexa number. So 0011010 is our question, and we will separate by 4 bits this time around. In hexa we need to separate by 4 bits, unlike when we convert to octal where we need 3 bits of numbers, and after separating them we need an hexa equivalent of the numbers. 100 does not qualify as a 4-bit number, so we will add 0 to the left side of it to make it a 4-bit number. Now 0110 is equal to 6 and 1010 is A. This will be our answer. 6A is the hexa equivalent of the question. We will take another example with the decimal number. Again, we need 4-bit numbers. After decimal, 01 is lacking 2 digits to become a 4-bit number. We will add double zeros to the right side of it. We can see from extreme left, 110 is also a 3-bit number. Add 0 to the left side of it. So remember, when there's a decimal question and a number after decimal is lacking any digits to become a 4-digit number, we will add zeros to the right side of it, and before decimal we will add zeros to the left side of it. Now after adding zeros, 3 chunks of 4-bit numbers, and we will have to find the hexa equivalent of them, which is 6a dot 4. 1010 is a in hexa terms. Now converting binary to decimal number, 1011 is our question. For this conversion we need to multiply each digit by 2 and add them. We need to add powers to the value of 2. We will add powers from left side to right in an incremental order starting from 0. So 0, 1, 2, 3 will be the powers. And after adding powers we will simply solve it, and 11 is the decimal equivalent of 1011. Take another example of binary to decimal conversion with a decimal number in it, 10.01. So again we will multiply by 2, but here's a difference without and with decimal point. We will add powers to each number, but the numbers that are after decimal will have negative powers starting from -1, and to the left side it will start from 0 and in an incremental order. And finally we will calculate all of the numbers and we get 2.25 as the answer. Thank you so much for watching.